Okay, in this playlist, I'm going to take you through direct and inverse proportion, and this is going to be the algebraic kind of stuff. So let's just talk about direct proportion first of all. We would say that things are directly proportional. You don't actually have to say the word directly. So we would say that things are proportional if, when one of the quantities doubles, so does the other. So for example, if we had a fixed amount of time that a car was traveling, the speed of the car and the distance that it traveled would be directly proportional, because let's say that the car was traveling for just, I don't know, 30 seconds. If you double the speed of the car for that 30 seconds, it will travel twice as far. And it doesn't have to just be doubling. It could be if you triple this one, you would triple this one, or if you halved the speed of the car, it would go half as far. This would also be the same with the number of calculators bought and the total cost. So if you doubled the number of calculators that you were buying in a shop, the cost would double. I've also asked this question at the end. What happens if one of these quantities is zero? Well, if the number of calculators bought was zero, then the total cost would also be zero. And if the speed of the car was zero, if it wasn't moving, the distance would also be zero, it wouldn't move. So if things are in direct proportion, both quantities would be zero at the same time. So what happens if one of these quantities is zero? So is the other. Now that only applies if it's direct proportion. I've said here, don't confuse direct proportion with positive correlation. So in correlation topic, you might have thought something like the temperature outside and the number of ice cream sold is that as the temperature increases, so does the number of ice cream sold. That would be a positive correlation. But this is not direct proportion, because if you doubled the temperature, you wouldn't necessarily double the number of ice cream sold. And similarly, this would not necessarily be true that both of them would be zero at the same time. So what would happen if one of these quantities is zero? Well, maybe if the temperature was zero, there would be no ice cream sold, but it doesn't mean that if no ice creams were sold, that the temperature would be 0 degrees. So direct proportion and positive correlation are not necessarily going to be the same thing. So let's have a look at direct proportion in a bit more detail with some numbers. And we're going to stick with this idea of a car which is traveling for a fixed amount of time. And we're going to try and fill in this table. So if we had that the speed of the car was 5 meters per second and it's traveling 150 meters, we can think about some of these other things that we would fill in the table. So if it's now traveling at 10 meters per second, it's traveling twice as fast. Remember, it's going for a fixed amount of time. It's probably going to travel twice as far. So that thing has doubled, which also means that this thing has doubled over here. Now, to go from the 5 to 25, we can see that the speed has increased by 5 times. So actually, I can also increase this by 5 times. And 150 times 5 is 750, so it would travel 750 meters. You can start seeing some of these other patterns that might happen. If we're going to go from, say, the 10 meters per second to 30 meters per second, that quantity is tripling, which means that the 300 is going to triple as well, and it would travel 900 meters in that time. And if the speed of the car is 0, the distance that it traveled would be 0 as well. So this table that we've got here is kind of the numerical representation of what's happening with direct proportion. And I've got some little extra bits of information over here. We say that D, and then this little symbol that looks kind of like the alpha symbol. Sometimes people say it looks like a fish symbol, but it's like the proportionality symbol. We say that D is proportional to S. So this little sign here means is proportional to. So D is proportional to S. Now the other way that you might write this is that D equals K multiplied by S, or D equals KS. And K is the constant of proportionality. K, as it is just a constant, is just going to be a number. Well, let's try and think about what that actually might be in the case of this, because there's some other things that we can probably notice from this table, is that to go from these ones on the left-hand side to these ones on the right-hand side, all of the numbers have a consistent relationship. And that consistent relationship that takes you from the left to the right is to multiply by 30, so that we can see the distance that you have is the speed multiplied by 30. And actually that multiplying by 30 is the fixed amount of time. It's 30 seconds that this car is traveling for. So in our example, we would say that to find the distance traveled, you take the speed and you multiply it by 30. So we would write that the distance is 30 times by S. In other words, the constant of proportionality in this question is 30. To find the distance that the car will travel, you take its speed and you multiply it by 30, and that is the constant of proportionality for this. Now, you probably know that kind of stuff already, but I wanted to set that out so that when we do these other kinds of questions in a moment, it will feel like it's kind of set in some context. Now, what I've also done is I've made a graph of these different points that we've got here, and I've connected them together to see if we can see what the relationship is. So I had this first bit here, this was 0, 0. This is if it's traveling at 5 meters per second. It travels 150, 10 and 300, 25 and 750, and 30 and 900. And you can see that these points here are connected together and they are making a straight line. And if we're saying that this is the speed along the bottom and this is the distance along the side, the equation of this line is actually the equation that we just came up with, which is d equals 30s. So the equation is d equals 30s. Now, normally when we see equations, we would say it was like y equals 30x. So we can think about what this 30 might represent. This 30, which was the constant of proportionality, this is actually going to be representing the gradient of the line. And you can think about that if you saw this graph, y equals mx plus c. This bit here is the gradient of the line. So the gradient of this line that we've got here is 30, okay? This is what direct proportion looks like on a graph. It looks like a straight line. So we're now going to go in and do some kind of algebraic ones, and then we're also going to have a look at the graphs that match with it as well. So this example says that y is directly proportional to x. Anytime you see that it says y is directly proportional to x, you can immediately just write down y equals kx with that constant of proportionality. If you wanted to, you could write down that y is proportional to x, but this bit we've got here isn't really necessary, so I'm just going to put brackets around it. I like to go straight into this thing that we've got here. It says when x equals 4, y equals 10. And it then says find a formula for y in terms of x. We're going to find a formula for y in terms of x, which really just means find out what k is. So I'm going to take this information that x is 4 and y is 10, and I'm going to substitute it in. So I can replace y with 10 and I can replace x with 4. Now I could write k multiplied by 4, or I could just say that that is going to be 4k. Now to find out what k is, I'm just going to solve this equation, which will mean dividing by 4. So I'll do 10 divided by 4, which is equal to k. And when you do 10 divided by 4, you get 2.5. You could have done 2.5, or you could simplify the fraction to 5 over 2. I'm probably just going to leave it as 2.5 though. So this means that our formula is going to be, rewriting this line that we've got at the top, it's just going to be y equals 2.5x. That is our formula for y in terms of x. Now part 2 of the question says find the value of y when x equals 2.1. So I'm going to use the formula that we've got, and I'm going to do 2.5 and I'm going to multiply that by 2.1. I'm going to be lazy and use my calculator, but you don't need to do this. You could have done a non-calculator method. So I'll do 2.5 times 2.1, which is 5.25. So the answer is that y is 5.25. Now you can see the 410 that we originally had when x is 4, y is 10. And now we can see that when x is equal to 2.1, which is down here, that y is about 5.25. So that should be about 5.25. It's not necessarily as accurately plotted as I wanted it to be there. Maybe I've done 2.2 instead, but we've got it roughly in this straight line that we've got here for direct proportion. So let's try another one. This time its calculator is allowed, and it's slightly different what it says at the beginning. It says that A is proportional to, it doesn't have to say directly proportional to, it could say just proportional to. A is proportional to the square of B. So you could write A is proportional to b squared. That's what the square of b is. But I'm going to put that in brackets because you don't have to do that part. We could just say that a equals the constant of proportionality multiplied by b squared. So the difference this time is it has the square of b. Now we're going to do the same thing as before. We are going to find out what k is equal to, and we're then going to use it to answer these questions. Now you'll notice it doesn't say, like this one did, find a formula for y in terms of x, but we're always going to do that. We're always going to find out what k is equal to. So it says when a is equal to 24, so I'm going to substitute a as 24, it says that b is equal to 4, so that's k multiplied by 4 squared. So that's 24 equals, 4 squared is 16, so that is 16k. Now I'm going to do 24 divided by 16. 24 divided by 16, and that is 1.5. So I get that k is equal to 1.5. Now going back to this original line that we had at the top here, a equals kb squared, I can now say that a is equal to 1.5, because that's my k, b squared. And I can use this formula that I have to try and help me to answer the next bit of the question. So I'm going to put this here, and it says find the value of a when b is equal to 2. So using this formula, I'm going to find out the value of a by doing 1.5, and I'm going to multiply that by 2 squared, because it says that b is equal to 2. So that's 1.5 times 2 squared. It does say calculator allowed. You could do this without a calculator, but 1.5 times 2 squared is equal to 6. So the value of a when b is equal to 2 is 6. The next part of the question, part 2, it says find the value of b when a is equal to 5, rounding your answer to 1 decimal place. So our formula is that a is equal to 1.5b squared, and they've told us this time that a is equal to 5. So I'm going to put 5 where a is, so 5 equals 1.5b squared, and we're now going to solve this equation. So I'm going to do the 5 divided by 1.5, that's equal to b squared. Now, because I've got a calculator, I'm actually just going to put this into my calculator. I'm not even going to work it out. But before I do that, I'm going to write down what b is. I'm going to say that b is the square root of that thing, 5 divided by 1.5. If you wanted to, you could have done the 5 divided by 1.5, but you end up with a decimal, and I don't really want to type that decimal back in. So I'm just going to do on my calculator immediately the square root of, using the fraction button, 5 over 1.5. And it asks for us to round our answer to 1 decimal place. So I'm going to say that b is equal to, let's get the calculator back up, 1.8. So b is equal to 1.8 in that case when it's been rounded to 1 decimal place. Now you'll notice on the graph that I've got here, I've got the values that we had in the question, okay? So we have the 424 which was given to us, and then we've got these 2 values that were being discussed. So the first one is when b is equal to 2. Now when b is equal to 2, a is equal to 6. And then we had when a is equal to 5, we got that b was equal to 1.2. So notice how this one, the way the graphs are connected is not a straight line anymore. They've been actually connected with a curved line. And this is the equation of the line that we have of this graph. The equation of this graph is a equals 1.5 b squared. The type of graph this is, it's a quadratic graph. And I'm mentioning graphs because at the end, we're going to want to think about how they are related to their graphs. Okay, I'm going to do, I believe, one more example, and then you're going to have a go. But this one is a non-calculator one. So it looks a little bit different, but let's just see how this one goes. So it says that f is directly proportional to the cube root of g. There's that extra word directly that it doesn't always have to have. So f is directly proportional to the cube root of g. It's going to look like this. But if you wanted to, you could just go straight in and say that f equals k, the cube root of g. Now it wants us to fill in the table. So I'm going to use this information that we've got here. That will help me find out what k is. Then we can find out these things. So this first part of the table is actually saying when f equals 3, g equals 3 and 3/8. Now, I don't think I'm going to be able to find the cube root of 3 and 3/8 in this form. So what I'm going to do to this is I'm going to write it as a top-heavy fraction. So if you remember how to do that, you do the 3 times the 8, which is 24, plus the 3, which is 27. So it is 27 over 8. Now I'm going to use that information to help me find out what k is equal to. So I'm going to take this f being equal to 3 and put it in here. And I'm going to take this g being equal to 27 over 8 and I'm going to put it in here. So 3 is equal to k multiplied by the cube root of 27 over 8. Now when you do the cube root of 27 over 8, you're going to do the cube root of 27 and the cube root of 8. So the cube root of 27, that is 3, and the cube root of 8 is 2. So to solve this equation, I'm going to get rid of this divide by 2 by multiplying by 2, so that 6 is equal to k multiplied by 3. And you can see that k is going to be equal to 2, but I'm doing that because I do 6 divided by 3. So k is equal to 2. So this means that our formula is that f equals, here is k that we've just worked out, and here it is in the formula. So f equals 2, the cube root of g. So we've done all of that just to find out what the formula is. We're now going to try and establish what is these two values? What are those two values that we have there? So the first one is when f is equal to 5. We're going to try and find out what g is equal to. So when f is equal to 5, I'll replace the f with 5, and then I have 2 and then the cube root of g. I'm going to divide by 2, so that I get 5 divided by 2 is the cube root of g. Now you need to think to yourself, what is the opposite of doing the cube root? The opposite of doing the cube root is to cube something. So I'm going to do 5 over 2, and I'm going to cube that number. Now, if you need to think about how you cube 5 over 2, because I'm a little bit low on space here, if you're going to do 5 over 2 cubed, that means you're doing 5 cubed and 2 cubed. 5 cubed is 5 times 5 times 5, which is 125, and 2 cubed is 2 times 2 times 2, which is 8. So we get that g is 125 over 8. So I'm going to fill that in up here, 125 over 8. If you wanted to, you could write it as a mixed number like this, but I'm kind of happy to leave that one the way that it is. And then our last one says that g is equal to 8. So when g is equal to 8, we're going to find out what f is. F is 2 multiplied by the cube root of 8. Now the cube root of 8 is 2, because 2 times 2 times 2 is 8. So f is just 2 times 2, which means that f is equal to 4, so I can fill that in on the table. Now you can see in the graph that we've got here, this is a slightly different kind of pattern. We had the first one, which was the 27 over 8 and 3, and then we have this one, which is the 8 and the 4, so you can see that when g is 8, f is 4, and then over here you can see that when g was 125 over 8, 125 over 8, I'll just quickly show you what that is as a number, 125 over 8, it is nearly 16, it's in between 15 and 16, you can see that you get that f is equal to 5. And this curve that we've got here also is not a straight line. This is because of the fact that we have a cube root in the equation. Cube roots look like this kind of shape. So that's all the stuff you need for directly proportional. This one here is going to be without a calculator, and then this one is going to be with a calculator. So pause the video, have a go at these, and see if you get the same answer as me. Okay, so the first one says y is directly proportional to x. You could write that if you want to, but I'm just going to say straight away that y equals kx. And it says when x equals 15, y equals 10. So I'm going to replace the y with a 10 and the x with a 15. So that means that I have 15k. I'm going to find out what the formula is, which means just find out what k is. So I will do 10 divided by 15 for k. And you can simplify that fraction. If you divide the top and bottom by 5, 10 divided by 5 is 2, and 15 divided by 5 is 3. So k is 2 over 3, which means that our formula, going back to the original part that we have, y equals kx, is going to be y equals 2 over 3x. That's that first part. We found the formula. We're now going to find the value of x when y equals 3. So when y equals 3, we would get that 3 equals 2 over 3x. So I'm going to try and get rid of this. I'm going to get rid of this bit which is dividing by 3 by multiplying by 3, so that 9 equals 2x. And then I'm going to get rid of this 2 by dividing by 2. And you could either write it as 9 over 2, or you could just give it as a decimal and say that x is equal to 4.5. Okay, the second one, it says c is proportional to the square root of d. So this is going to be that c is equal to k, the square root of d. Given that d equals 16 when c equals 5, find the value of c when d equals 3. Okay, so first thing I'm going to do is find out what k is equal to. So it says that c is equal to 5 and that d is equal to 16. So the square root of 16 is 4. So I can either write k times 4, or I could write 4k. Now I'm going to find out what k is by dividing by 4. So I will do 5 divided by 4 is equal to k. And you could work out that on a calculator, but 5 divided by 4 is 1.25. So k is 1.25. That means I'm going to take this and I'm going to rewrite the original formula so that c is equal to 1.25 times the square root of d. Now we found out what the formula is. It says find the value of c when d equals 3. So c is going to be 1.25 the square root of 3. And I can literally just type that straight into my calculator to see what it gives us. So I'm going to do 1.25, the square root of 3, they're being multiplied, and it wants it to 2 decimal places, so I will do 2.17. So the value of C is 2.17 for this. Now this one, which was a directly proportional, if it was going to ask what it looks like on a graph, it would look like this. This one is a square root or cube root graphs tend to have that kind of like arching shape like this, if you wanted to think about what these would look like as a graph as well. In the next video, I will be doing inverse proportion, so stick around because that's also part of this topic. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.